Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answers. You have quiz about sound waves, paper 1 for core and extended candidates. And the extended candidates, please check you have assessment about paper 2 for extended candidates only. Okay, let's start by question number 1. Question number 1. You have a candle flame placed in front of loudspeaker, and the question is asking you which row showing the direction of vibration of the candle flame and the nature of sound waves. For sure you know that sound waves, they are longitudinal waves, so you have to exclude B and D because you know the nature of sound waves, they are longitudinal and mechanical. What do you mean by mechanical? Waves, they require a medium to travel through it. Okay? What about vibrations? Longitudinal, as we said earlier in general wave properties, you know that particles vibrate along the direction of wave travel. So if you have, this is the direction of wave travel, so wave travel in this direction. Okay, how the particles will vibrate? The particles vibrate to the right and to the left along the direction of wave travel. So you have to choose the direction C, direction of vibration. So particles vibrate along the direction of wave travel. Let's move to question 2. In question 2, a student finds that sound waves, it took 0.33 seconds to travel 100 meters. From this information, how can you calculate the speed of sound waves? Sound waves can be calculated using the general equation for speed. So speed is equal to distance traveled divided by time taken so you can substitute now the distance traveled 100 meters. Check that you have consistent units, and please, if you have 0.33 seconds, you have to only round your final answer. Only the final answer should be rounded, okay? So that you will get your result, your final answer, 300 meter per second. So the correct answer is C. And again, guys, one more time, you have to check your final answer should be realistic. What do you mean by realistic? You know already the range for the speed of sound in air, so you can if you have your answer, for example, 100, so it's not realistic. So you have to check your final answers to be realistic. I have to move to question 5 because some questions, they are repeated in our already in our classwork. So I have here question 5. Question 5, a student stands 180 meters in front of vertical flat cliff. You have to revise the characteristics of any reflector, the reflecting surface. Sound will be clearly reflected. You will get clear echo if the surface is large, hard, and flat, a smooth one. so the sound waves will not be absorbed by the surface. So you have the reflector or the reflecting surface should be vertical, flat, hard, and smooth. So large wall or cliff, this will be very good for your reflection. Okay, and what about the sound of echo? The sound of echo should be also short and loud. It will not be continuous one. You have here the time records the echo of sound 1.5 seconds after the sound is produced. Based on this result, what is the speed of sound? You have to apply the equation we are using. You have to apply the equation we are using in this case. You have to apply speed of sound is equal to 2 times distance from the cliff divided by echo time. Don't write time, you have to write down echo time. When you substitute, you have here 2 times the distance from the cliff. It's 180 meters. Check that you have consistent units, and the time taken here, it's 1.5 seconds. When you get your final answer, it's 240 meters per second.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.